it's time for us to get started. Jon Blum has been a member of this club for 10 years now. He was our president the last 2 years and vice president before that. And this is the 13th presentation he has made to our club. Past topics have included astronomy gadgets and astronomy trips. He really likes taking trips and brings us reports on them. He's going to be doing that tonight. I remember he gave one talk on the 7 astronomy clubs that he's a part of. 3 in Hawaii and 4 here in Michigan. He's a retired dermatologist. He originally joined some astronomy clubs to learn how to use a telescope, then stayed on to learn from the presentations at our meetings, and now he's gotten to know a lot of people and he enjoys socializing. A recent trip that he was on went to Chile, and so tonight his presentation on that trip is entitled Southern Hemisphere Skies. I'm looking forward to hearing this, as I'm sure you are too. Right?
I went on a Sky and Telescope organized astronomy tour to Chile the last 2 days of March, first 2 days of April this year, in order to see some objects in the sky that you can't see from here in the north. Now, when I have to give a talk to the club, I can't very well be teaching physics when Dale Parton's in the audience. And I can't talk about astronomy history if Ken Burton's going to be in the audience. And of course, only Jim Shadlowski can play a guitar at the end of his presentations, as we're going to hear next month, I hope. And Bob Burton does astrophotography, which I would never dare even attempt. And I'll never be able to speak as well as Gary Ross. So I give my talks on usually one of these 2 topics. I've given several talks on various astronomy gadgets, like these blinky lights shown in the picture that are at the base of my tripod to keep you from tripping over it. Or travel. I've gone on several astronomy trips to various places in order to collect things like this Kid Peak shirt that I'm wearing tonight. So those are usually my 2 topics of conversation. Sky and Telescope magazine arranges astronomy-themed trips to several places each year. I went with them to New Mexico in 2004 and saw the very large array, a really spectacular sight to see. Last year, my wife, who's here in the audience with us tonight, and I went to Iceland to see the Northern Lights. We unfortunately didn't see much Northern Lights, but we got to see a lot of Iceland, and we got to be cold in the dark and see some beautiful waterfalls. This year, they offered a trip to Chile to see the Southern Hemisphere skies, so I went to the observing and stayed for the earthquake. Jerry Dunford is a member of this club, and I met him on the Iceland trip. He hadn't come to this club meetings before that, and I met him on the trip a couple years ago in Iceland. I talked to him into coming to our club meetings here, and he told me about this wonderful trip to Chile that he had done, and he's really the person that got me interested in going on this trip. So I looked at the Sky and Telescope website where they advertised the trip. They gave the itinerary and the cost. It involved 9 days in Chile, plus overnight flights to and from Chile. They scheduled sightseeing each day and observing each night. It's all organized by Spirit Travel. This is a travel agency in Oklahoma that does the logistics and organization for Sky and Telescope tours. The price of the tour, the package was $4,650 per person double, or $5,400 per person single occupancy. Plus you have to add the airfare round trip from here to Santiago, was $1,514. Most of the meals weren't included, so the total cost was about $7,300. And if you did it in Chilean pesos, it was millions, so you could really feel like you were rich. But I got a free name tag. All of you know how I feel about name tags. And you get to stand stand under the center of the Milky Way. This is something we can't do here. The center of the Milky Way is low on the horizon. As you know, it's in what we call the steam coming out of the teapot in Sagittarius. And we only get to see it very low, but in the southern hemisphere, you can stand right underneath it. So day one, we had to fly overnight. Strangely, all the flights from here to Chile and from Chile back here are all overnight flights. So we had to fly overnight, leave Detroit late in the evening, arrive in Chile early in the morning. I don't do astrophotography, as you can see by this example, but I held up my camera to the window of the airplane and got a picture of Venus and the moon towards the end of this overnight flight. It's about 5,300 miles from here to Santiago. It takes about 2 hours to fly from here to Atlanta. We can catch a Delta flight that goes from Atlanta to Santiago in about 10.5 hours. So it's about 900 miles further than from here to Hawaii. Well, the first day they didn't plan anything for us in an organized fashion because people were arriving at different times of the day and everybody was tired from their overnight flight. So there was no organized tour plan the first day. But a few of us that had just met at the hotel or at the airport decided to go out on a walking tour on our own and look around the city a little bit. It was a great group of people on this trip from a wide variety of places. So one of the fun things about going on a trip like this is just meeting interesting people. The fellow on the left is from Prague, the Czech Republic. Then there's me, there's a guy from the United Arab Emirates from some city I never heard of there. And the woman on the right is a native American Indian, Mohawk Indian. So just an example of great, interesting people you get to talk to on a trip like this. Then we got to rest up the first night, and the second day we were all alert and rested and ready to start our organized tours. And the trip had a planned city tour of Santiago. They took us out by bus, drove us around the city, and then parked the bus in several places and did walking tours around parts of the city. It was just a city hall building that we looked at. We went to a racetrack. I'd never been to a horse racing track before. There wasn't a race going on, but there were some horses practicing out there. We went to an interesting restaurant that day for lunch. This was a huge steel girder building with just one giant room, just one floor. And when you walk in the room, you see lots of tables all over with red tablecloths on them, but they're all different restaurants. Each restaurant only had a handful of tables. But when you walk in the door of the building, you get accosted by representatives of each of the restaurants telling you why their restaurant is better than any of the others and why you should go to their table for lunch. They have a lot of outdoor fruit stands in the city in Santiago. They had some outdoor fish markets. And an interesting thing I'd never seen any place in the world, when you stop for a red light in downtown Santiago, some acrobats run out in front of the cars that are stopped for the light, do a couple of tricks, and then run from car to car asking for donations to pay for these tricks they just did for you. And all this happens in the 45 seconds or so that we're we toured a few churches. Chile was settled by Spanish people, and so we have a lot of European-looking churches here. And it's much like taking a tour of any downtown European city where you see these beautiful old churches. Well, that night we went for our first observing night. We went to a place called Catholic University Observatory. It's just outside the capital city, so the location wasn't real dark. But we were able to see some objects that are bright enough to see naked eye, and we did look through a couple small telescopes. On the left side, you can see our first view of the Southern Cross. Oh no, sorry, we're on the wrong slide. This is our a view of Leo. Leo is upside down in the southern hemisphere. Here you can see Regulus at the top of the question mark, and here's the question mark. We usually would see this right side up. Here's an upside down question mark, and here's the tail of Leo. The triangle that we see is the tail. So here's upside down Leo, and here's upside down Orion. Here's the belt. The sword we usually see hanging down from the belt. There it's hanging up from the belt. And then Rigel that we usually see at the bottom of Orion is up at the top. Betelgeuse, red giant that we see at the top of Orion is down at the bottom. So, of course, the constellations aren't upside down. We're upside down when we're standing in the southern hemisphere. We also got to look at Jupiter, Mars, the Orion Nebula, and then our first look at some southern hemisphere objects. So here's the Southern Cross. It's probably the one constellation in the southern hemisphere that everyone has heard of. Crux is the name of the Southern Cross. It's the smallest constellation, only 6 degrees from top to bottom. It has 5 stars brighter than third magnitude. Alpha Crux, the brightest star, magnitude 0.8 is the southernmost first magnitude star, though it's really the combined magnitude since it's a double star. Crux is sometimes visible any place south of 25 degrees north latitude. So you can see Crux from Hawaii. We're at 21 degrees latitude in Maui. Crux is so circumpolar when you're south of 23 degrees south latitude, which we were during the entire trip. So Crux is always visible in the sky. Here's, I think, my only other astro image from the trip. And it's just a handheld image of the Southern Cross. It's lying sideways at the top of the picture here. This is the jewel box. The jewel box, NGC 4755, is a naked eye, fourth magnitude open cluster. It's 1 degree from the beta star, the second brightest star in Crux. It's a young cluster, 14 million years old, contains about 100 stars, and is 6,400 light years from the Earth. I had to look up the origin of this for Ken. This was named by Sir John Herschel. He described it as a casket of variously colored precious stones. Well, Omega Centauri is a famous bright globular cluster, the biggest and brightest globular cluster, and many of you have seen it because you can see it from many parts of the United States. Magnitude minus 0.3, it's the third brightest star in the night sky. After Sirius and Canopus, Alpha Centauri is the third brightest star in the sky after Sirius and Canopus. It's 4.37 light years away. It's a double star, the closest naked eye star to Earth. Beta Centauri is a triple star, 0.6 magnitude, and Omega Centauri is a naked eye globular cluster that I'm going to discuss later. This photo was taken by one of the people on our tour group and gives a good idea of what the naked eye view of this was. Here's Alpha and Beta, which are stars, and Omega, which looks a little grayer because it's a globular cluster rather than a star. Proxima Centauri is slightly closer to us than Alpha Centauri. It's the closest star to the Sun. It's a red dwarf, 4.24 light years away, but it's not visible to the naked eye. It's 11th magnitude. We didn't observe it. The reddish glow in the mid-right part of this photo is the naked eye view of the Orion Nebula, and we're going to talk more about it later. Of course, it doesn't look red naked eye, but it is large and bright nebula. And the Tarantula Nebula is the gray glow in the middle part of this photo. This gives you an idea of the naked eye view, and we're going to talk more about it later. I tried to pick pictures that are not bright, colorful Hubble pictures, so I do have some Hubble beautiful pictures in here as well. But for the most part, I tried to look for pictures on the internet that looked something like what we really saw. For the naked eye view like this, I tried to give you an idea of what it really looked like naked eye by searching through the web to find a few black and white pictures instead of just pretty color pictures. Here's 3 constellations we learned. Centaurus, like Sagittarius, is a constellation representing a centaur, half man, half horse. Carina and Vela are the keel and the sail of the former larger constellation Argo Navis. That was the boat that Jason and the Argonauts used. The third part of that ship is Phoebus, the poop deck. So this is the end of the naked eye objects that we were looking at on our first night in Santiago. Next day, we flew to La Serena, a smaller town. Here's a map of Chile. As you probably know, Chile is a long, narrow country on the western coast of South America. Santiago, the capital, is in roughly the center of the country. It's the only city you can fly into from the United States, so we had to fly into Santiago and then go from there 300 miles north to La Serena, and then take a bus inland about 40 miles to a tiny town called Vicuna that's not shown on the map to try to get to the dark sky areas. You notice these planes on these, here in Chile, they didn't have the jetways. We have to pull up the plane, so we actually walked up and down stairs onto the tarmac like in the old days getting off on an airplane. Chile is actually east of Detroit, even though it is on the western edge of South America. It's in the same time zone as we're in. But the longitude is about 70 or so. We're at about 83 or so it's further east than we are. We went on a group tour walking around this little tiny town of Vicuna, just 24,000 population. It's the kind of little town you want to be at for astronomy, so you don't have big city lights. Like in a lot of small towns here in Chile and small towns in Europe, there were musicians playing out on the street, typical small European-looking churches, a town square with a fountain in it, and something I have never seen in any place else, which is just pianos permanently sitting out on the city square and in various marketplaces. I don't know how they survive the elements of the rain there. But they have pianos out there because anybody can sit down and play the piano.
Huh.
Well, that night we went to a place called Calavera Observatory. This was also a picture taken by one of the people on our group. Most of the pictures I found on the internet, so this was taken by somebody on our tour group. Up here you can see Rigel and Orion. Over here you can see Castor and Pollux, the twins, and here you can see Jupiter. This is what this observatory building looks like in the daytime. It's a pretty building. We didn't get to see it in the daylight, so I had to just get this picture of it. It's an observatory for the public 37 miles from La Serena on a mountain at about 4,000 feet elevation. It's run by a nearby small town. We only have a 14-inch Meade LX200 SCT. On the outside decks, there are a 16-inch Dob and a 10-inch Newtonian. And in the building is an auditorium that seats 54 people for beginners astronomy talks. So they get enough people to come out here and listen to these talks to keep this building going, to have a safe running a town like an observatory like this. Here's their SCT in the dome, and me standing outside of this curved, pretty architecture on the outside of the building. Now we'll talk a little bit about Omega Centauri. This is the largest globular cluster in our galaxy. It contains stars of a variety of ages, unlike other globs that have stars of all similar ages. So Omega Centauri may be the core remnant of a disrupted dwarf galaxy. It's 15,800 light years away, and it's visible to the naked eye at fourth magnitude. Its apparent diameter is about half a degree, the same as the moon. It contains several million stars, and the center is so crowded that the average distance between the stars is only 1/10 of a light year, 600 billion miles. Its declination is minus 47.5 degrees. So theoretically, it can be seen from any place a little south of Detroit when it's highest in the sky, which for us would be barely above the horizon around midnight in the spring. It's easily seen from southern states like Florida, Texas, and Hawaii. Gary Ross gave us a talk one day here a few years ago about trying to see Omega Centauri from close to Detroit, where it'd be right on the horizon. 47 Tucani is another globular cluster that looks quite different. At fifth magnitude, this naked eye globular cluster is the second brightest in the sky after Omega Centauri. It contains millions of stars and is 16,700 light years away. Like Omega Centauri, it appears about half a degree in diameter, but its stars are much more centrally concentrated. It's much farther south at minus 72 degrees, so it cannot be seen from any place in the U.S. Its total mass is 7 times 10 to the 5th solar masses, almost as much as Omega Centauri's 4 times 10 to the 6th solar masses. So this is a very interesting comparison, because we're always looking at M13, our biggest, brightest blob here in the northern hemisphere. So I know all of you are very familiar with M13, the object shown on the left here. So here we have the same magnification. You see the line there marking 30 arc minutes. 30 arc minutes, of course, is half a degree. So the full moon would be the width of that line, half a degree line. So you can clearly see the difference. M13 in Hercules, the biggest and brightest glob that we see, is 6th magnitude. It's 22,000 light years away and contains a few 100,000 stars with a total mass of 6 times 10 to the 5th solar masses. And it looks really big to us here, but it looks pretty puny next to Alpha, next to Omega Centauri, and next to 47 Tucani. By the way, when you look at these with the naked eye, with M13 we see just a little blur. With Omega Centauri you see a big blur. With 47 Tucani it almost looks like a star because it's so centrally concentrated that you don't get much blur when you're looking at that naked eye. My favorite of the objects I observed in the southern hemisphere is the Tarantula Nebula. It's in the large Magellanic Cloud 160,000 light years away. Like the Orion Nebula, this is an H2 region, meaning a low-density region of partially ionized hydrogen gas, in which star formation has recently taken place. The newly formed stars emit ultraviolet light that ionizes the surrounding gas. The closest supernova since the invention of the telescope was seen here in the Tarantula Nebula in 1987, and was naked eye at magnitude 3. The nebula's magnitude is 8 compared to 4th magnitude for the much closer Orion Nebula. The Tarantula Nebula looked like this to me in a 14-inch SCT, with amazing intricate details, much more complex than the Orion Nebula, which used to be my favorite telescope object. I I found this picture on the internet looking again for trying to show you a picture of what it really looks like. What I always love about the Orion Nebula is the detail that you can see in it by staring at it for a long time. And then all the more so in the Tarantula Nebula. I think one mistake that people new to astronomy make, and that I made for my first few years in astronomy, is taking a quick look at something for 5 seconds in the telescope. And one thing I learned with experience and a lot of help from people in this club is that if you look at something for 2 or 3 or 5 minutes in the telescope, you see tremendously more detail than when you just look for a quick glance. Here's a Hubble view of the Tarantula Nebula. Of course, nothing like you really see in the telescope, which just to give you an idea of what a good astrophoto of it would look like. The Tarantula Nebula is about 100 times as far away as the Orion Nebula. If it were at the Orion Nebula's distance of just 1,500 light years, it would appear 30 degrees wide in our skies. Tarantula is 1,000 light years in diameter, while the Orion Nebula is 24 light years. At our distance, the Tarantula appears 40 by 25 arc minutes, while the Orion Nebula appears 85 by 60 arc minutes. The large and small Magellanic clouds are irregular dwarf galaxies that probably orbit the Milky Way. The large cloud is 160,000 light years away, while the small cloud is 200,000 light years away. They're 75,000 light years apart from each other and appear 21 degrees apart in our sky. There are 14,000 and 7,000 light years in diameter. The large cloud appears 11 degrees by 9 degrees, while the small cloud is 5 degrees by 3 degrees. For comparison, the bowl of the Big Dipper is about 10 by 5 degrees, so you can get an idea that these clouds are of the order of magnitude of the size of the bowl of the Big Dipper. Their declination are 70 degrees south and 73 degrees south, so they can't be seen from any place in the United States, not even from Hawaii. They view just barely below the horizon on the map. To me, they looked a little dimmer than the Milky Way, but they were very easy to see in a dark sky sight. Well, Vicuna, the small town that I mentioned before where we saw the pianos on the street, had the only bad accommodations of our trip. We stayed 3 nights in a hostel with no heat or air conditioning, minimal lights, low water pressure, transparent window coverings so people on the sidewalk right outside the rooms could see in, and a tiny shower with curtains that touch your body on all sides. But this was the fanciest hotel in this town, and it put us on a dark sky site, so it's still a great place to be. In the daytime, we went to see a professional observatory, Centauri. Those of you who toured professional observatories know that you generally can't get in there at night and you can't look through their telescopes, but you just go there in the daytime to see what the telescopes are like. This is the only cloudy day we had on our trip. We had no cloudy nights on our trip. We had clear skies every single night. And just this one afternoon when we happened to be there, it happened to be cloudy in the daytime. They have 7 telescopes here. It's at 7,000-foot elevation. We had a guided tour of the telescopes and got to sit in the control room. I've been to several professional observatories before, but I never got to sit at the chair in the control room. So to me, this was a great treat to pretend to be like a professional astronomer. As you know, professional astronomers don't sit at the eyepiece of their telescopes. The telescope is in a big dome at ambient temperature, and the astronomer is in another room someplace else, a warmer room with controlling everything through computers. Bob Noya, the editor of Sky and Telescope, was one of the 29 people on our group tour. He's a great, friendly, knowledgeable guy and taught us a lot in talks and conversations at every site and observatory, as well as on our bus trips, at meals, and in our hotel. So on the left you have me with Bob Noya, proudly showing him I wore an Astronomical Society shirt. And on the right side you see our tour group of 29 people. This is the Blanco Telescope at 4 meters. It's the largest telescope at Cerro Inter-American Observatory. It's similar to the 4-meter Mayal telescope at Kitt Peak. It's the main research instrument for the dark energy survey using wide field camera. That night when it went observing, again, we couldn't observe at the professional observatory, so we had to go to an amateur observatory place for observing each night. So we went to Alpanghi Observatory. And interesting thing to notice in the left picture, you've seen 1,000 pictures of the northern hemisphere sky. They look like that picture on the left. And they all have Polaris in the center, barely moving at all. So you notice in this picture of the southern hemisphere sky, there isn't any star in the center because they don't have a nice bright naked eye pole star like we've got here in the north. There's not any almost non-moving star in the center of the circle. El Paine is 10 miles from Vicuna at 4,900 feet elevation, 30 degrees south latitude. It's a private for-profit observatory to show the southern skies to tourists. To get there, we have to ride an hour each way on a rough, winding mountain road in our tour vans. We used their 25-inch Dob and their 16-inch SCT. Each was operated by one of the two owners of the observatory. They're both very knowledgeable people and give us a lot of great information and great sights to see. At the end of the night, when we weren't going to ruin our night vision, we took a turn climbing up in the ladder next to their 25-inch Dob and taking each other's pictures. This is the darkest place we observed on our entire trip, and the most hours we ever spent out observing. We were there from 9:30 p.m. to 2:15 a.m. Most nights we ended about midnight so we could get up the following morning for tours, but this night we stayed up particularly late at our darkest spot of the trip. The spectacular Tarantula Nebula and the 25-inch Dob at this dark site is the most fabulous object I've ever observed. I kept looking at it over and over and gazing at it for a long time. When I saw it in an O3 filter, it almost looked three-dimensional. The second best object I observed here was 47 Tucani, again getting a longer time to look at it, seeing more detail, the concentrated center, and then the scattered stars on the outlying area. Well, here's some objects that we're all familiar with that we can see in the northern hemisphere, which they also showed us at this site. It was still good to see them, even though we've seen them many times before. But seeing them in a dark sky site in the Big Dot is always wonderful. The Sombrero 104, the Orion Nebula, M46, that's the cluster with the planetary in it, the M4 globular cluster with the Lagoon Nebula, and the Leo trio of galaxies. We also took a look at the Ghost of Jupiter, or planetary nebula. And then next few slides I'm going to show you some southern hemisphere objects that are not like these northern ones, things that we got to see that we don't see up here. The Large Magellanic Cloud, you can spend a week, I think, in Chile just looking at this one object because it contains numerous other objects, and they're all ones I'm not familiar with because we don't see them here, of course. But there's numerous clusters, open clusters in the Magellanic Cloud and numerous nebulae in the Large Magellanic Cloud, and you can just sit there forever with a big dot pushing it around the cloud and looking at fascinating objects. Here's just one little section of the Large Magellanic Cloud. They abbreviated NGC, it's just N in here, so these are all NGC objects, mostly open clusters in the cloud. I should mention, and perhaps you all know this, but the Magellanic Clouds were named by Magellanic, who was the first European to see them. At first glance, they looked something like clouds. I don't think that Magellan or anybody would be confused for very many minutes thinking they were really clouds, because of course they don't move and they're in the same place every night. NGC 1910 is an open cluster with nebulosity in the Large Magellanic Cloud in the constellation Dorado. So this is just an interesting open cluster because of the nebula in it. Centaurus A, this is an object in Centaurus, is the fifth brightest galaxy in the sky. It's 13 million light years away. It has a bright central bulge and a dark dust lane visible even in small telescopes. It ejects radio jets over 1 million light years long, but you can't see the radio jets. I couldn't find a good picture of what this really looked like to me in the telescope, but of course it would be black and white, and what you could see was a diffuse blob and then a very clear, wide, dark dust lane going across the center of it. The Atacama Nebula, it's the large red area in the center of this photo. It's 7,500 light years away in the constellation Orion. This is the brightest nebula in the sky, even brighter than the Orion Nebula, and 4 times as large as the Orion Nebula. Easily visible naked eye, but of course appears gray, not red like in the photo. A closer look at the Atacama Nebula, NGC 3372. The dimensions of this whole photo are 3 degrees by 2.5 degrees, so you can get an idea this thing's pretty huge. The nebula contains several open clusters and several massive stars. The largest star is Eta Carinii, a hypergiant with a mass of 100 to 150 times the mass of the Sun, and luminosity 4 million times that of the Sun. It could go supernova or hypernova at any time soon. I'm sure all of us are going to go back to the southern hemisphere if that happens. Take a look at that. Inside of the Eta Carinii Nebula is a much tinier nebula called the homunculus. Homunculus means little man. This is an emission nebula surrounding the massive star Eta Carinae. It was created by an eruption of that star, which was seen from Earth in 1841, temporarily making Eta Carinae the second brightest star in the night sky. This is comet Jacques, which actually is visible here now. Had just been discovered when we were there in Chile. Had just been discovered, and it was in the southern hemisphere, moved into the northern hemisphere in May. Here's an object we can see here. B86, the ink spot or ink blot nebula, is a black nebula in Sagittarius. It's easy to find because it's adjacent to an open cluster, so you can zoom in on this open cluster, and that's a good way to find this dark nebula. This is the only tour I skipped. This is day 5, and we're still in this town of Vicuna, and this was the morning after that night that we were out observing till 2:15. Then we had the hour ride back to the hotel, the sticky wall shower. Didn't get to bed until about 3:30. They wanted us up at 8 o'clock to go see a tour of some farming country, so I decided I had farms here, but skip that tour. It was a place called Elky Valley. I was glad to catch up on my sleep, not only from that night, but from the previous several nights, because even though we were only up till midnight in the previous nights, we still had to get up too early in the morning for me. So if I was planning this trip, I would have scheduled no tours in the mornings, but that's not the way they do it. So if you want to see the sights, you got to get up and about. But this day, even though I didn't go on a tour, I did see a herd of goats, and that got me in the mood to eat goat for dinner. So I ordered goat at a restaurant. Tasted a lot like beef, but a little stringier. That night, after I had a good rest, went to a place called Magellanic Observatory. This is a municipal observatory run by a local astronomy club and sponsored by Tarantula Professional Observatory. It's 6 miles from that little town of Vicuna. We use a 12-inch job and a 16-inch SCP. They also do exclusive tours for the public and charge people for the tours, including a lecture and views through their telescope. Our visit there was included in their Chile tour package, but their usual charges for the public are $32 per person for a 4-hour tour with a minimum of 4 people. I was fascinated by this because we're always begging people to come for nothing and look through our telescopes and let us show them the night sky. And here they get people to pay $32 to come and look through the telescopes and give them a little lesson. And this wasn't the only place that I mentioned. The other place, El Pangi, that we were the previous night, had the same system. They charge people to come and look through the telescope and show them the night sky. Maybe we charge money to get more people to come.
We charge the fee.
How much do you charge?
$3.50 for an adult.
Okay, no more free observing night. At Mamaluca this night, we got a laser pointer tour of the southern constellations. We observed some objects that I already talked about on previous slides. Jupiter, the Centaurus A galaxy, that's the one with the big fat dark dust lane going through the middle. The Omega Centauri globular cluster, that's that largest globular cluster, the more diffuse one. 47 Tucani, that was the globular cluster that was more centrally concentrated. The Eta Carinae Nebula, that largest nebula in the sky. The Homunculus, that tiny nebula inside of Eta Carinae. The Tarantula Nebula, my favorite new object. The Jewel Box Open Cluster, and the Leo Trio of galaxies. Then we took a look at some additional objects that we hadn't seen on previous nights. This one's called the Football Cluster. It's an open cluster in Carina, the Keel, 1,300 light years away. Contains 150 stars, including 7 red giants. I don't recall ever seeing an open cluster with this many red stars in it. This cluster is nearly a degree wide, but too dim to see naked eye, also called the Wishing Well Cluster. In 1990, this was the first object ever observed with the Hubble Space Telescope. I can't imagine why they chose this as the first object to see, but I would have picked the nebula, I think. We were able to split Alpha Centauri. Alpha Centauri is the closest naked eye star to the Sun, 4.37 light years away. It's a binary star, Alpha Centauri A and B, which orbit their common center of gravity for 80 years. Their average distance apart is about the distance from the Sun to Neptune, and from here they appear between 2 and 22 arc seconds apart, depending on where they are in their orbit. A is slightly larger and more luminous than the Sun, while B is slightly smaller and less luminous than the Sun. They have a combined magnitude of minus 0.3, but measured separately, A's magnitude is 0 and B's is 1.3. If we could see B apart from A, it would violate the general rule that every star we can see naked eye is bigger and brighter than the Sun. This is an interesting rule to tell the public. I'm sure the public doesn't realize this. We always hear the sun is an average star. But all the stars are so far apart that we don't see average stars naked eye. So when you go out to observe even in a dark sky spot, you're only seeing bright stars. Average stars can't be seen because all the stars are so far away. So in general, when you see stars without a telescope, you're seeing stars bigger and brighter than the sun. Not seeing average stars or smaller stars, even though there are plenty of those. The coal sack is the easiest dark nebula to see in the night naked eye, as it's silhouetted against the southern Milky Way. It's 600 light years away in the constellation Southern Cross. It's about 30 light years across. To us it appears 7 degrees by 5 degrees. So the coal sack dark nebula that you see here is roughly the size of the bowl of the Big Dipper. Well, the next day we flew to Atacama. Now you can't actually fly from La Serena, where we were the previous few days, to Atacama up here. So you have to go back to Santiago. We were in La Serena. We had to fly down to Santiago, the capital city, an hour, and then go 2 hours up to get to the Atacama Desert. We went to San Pedro de Atacama. It's a town of 5,000 people at the 7,900-foot elevation. Here again, you see it's getting on and off the plane on just the stairway. The Atacama Desert is the driest place on Earth. It's a 600-mile strip in northern Chile, west of the Andes Mountains, covering about 41,000 square miles. It includes stony terrain, salt lakes, sand, and lava. The elevation varies between 1,000 feet and 13,000 feet. The average rainfall is 1/2 inch per year, but some areas never receive any rain. The reason it's so dry is that it's between two tall mountain chains, the Andes and the Chilean coast range, which prevent it from getting any moist air from either ocean on either side of the continent. Parts of the Atacama have been used to film Mars scenes, including a BBC TV program called Voyage to the Planets and Beyond in 2004. Tests to search for life on Mars, done by the Viking 1 and 2 landers and the Phoenix Mars lander, were duplicated in the Atacama Desert and did not find any signs of life in the areas they tested. Here's a view of the Atacama Desert from the plane as we were flying in. You can barely see some windmills here for generating electrical power. And here's a view from the bus. Spent many hour on our bus getting around to these towns and taking sightseeing tours. For most of the time we had a big, beautiful, air-conditioned, ultra-modern bus. Sometimes we had to go in smaller vans to get to off-road places. There were some towns we passed by that I don't know how possibly stand up to Chile's earthquakes. These look like little shacks. There is some life in some parts of the desert that get a little bit of rain, so we did see some cactuses. There's some drier parts of the desert with a volcano in the distance. Surprising, our hotel here in the Atacama Desert was the nicest hotel we stayed at on the entire trip. This is a beautiful, very new, modern hotel, just 1 story tall, big, ultra-modern rooms, big showers, lots of space. We did not get to go to Alma or Paranal, some places you may have heard of in Chile and wondered about. They were too far away from our tour route and would have required too many hours of bus riding to get to them. Alma is the Atacama Large Millimeter Submillimeter Array, which consists of 66 39-foot and 23-foot radio telescopes. Paranal is an observatory that includes the Very Large Telescope, which consists of 4 separate 8.2-meter telescopes. Well, there was no earthquake on the itinerary schedule we received for this trip, but nevertheless, we got to experience one. And that was the night of the earthquake, this night of our trip. We were riding on our tour van up a long, rough mountain road to get to our observing site when the first earthquake occurred, so we didn't feel it because we were bumping on the bus. But as soon as we got out of our van at the site, we could see the lamps swinging in the ceiling of the office building, and a moment later we felt the ground move under our feet as we stood beside the van. It was the first time I ever felt an earthquake. It was magnitude 8.2 and came at 8:46 p.m., but it was centered about 500 miles from our location, so it didn't do any damage close to us. They predicted a tidal wave, but we were a few thousand feet elevation, so we had no worries about tidal waves. Back in the hotel room later that night, I was awakened by my bed shaking. when there was a 7.7 magnitude earthquake. I also felt the room shaking when I was getting dressed the next morning. They had to go through a lot of trouble to try to think of some words that would spell space when they used the initials. But this is where we went observing the next night at the San Pedro Atacama Celestial Explorations. This was our one night of observing the Atacama Desert. It's at 7,900 feet elevation. It's the largest public observatory in Chile. Two men, a tourism expert and an engineer, started in 2003 and are constantly adding more telescopes and expanding it. They've had 100,000 visitors so far. They normally put on a 2.5-hour astronomy tour, again $32 a person, though our stay was much longer and was part of our tour package. We didn't see the place in the daytime. This is what an aerial view would look like, or if we went up and Mike would down his little device to look down on it to get some aerial views. You can see they have wide cement pads with their telescopes set on it. They have 10 telescopes from 8 to 24 inches all set up on this large observing field. We did most of our observing with the two 18-inch and two 24-inch dials. I got to meet Fred Espinec here. He was leading a different unrelated tour that just happened to be at the same site on the night we were there. He's Mr. Eclipse and a friend of Ken Burton since they've been on several solar eclipse tours together. I asked Fred how to prepare for the total solar eclipse that we're going to have here in the U.S. in 2017, and he advised making reservations at some hotel on the eclipse path more than a year in advance, and staying mobile so we can drive a couple of hundred miles along the eclipse path if necessary on the eclipse day to look for clear skies. So I think this is some valuable advice, and I think even though that eclipse that we've been waiting for, the first solar eclipse here in the United States mainland for several decades, his advice was to prepare more than a year in advance. I was planning to prepare a year in advance. I've already started looking at weather patterns. If you Google this 2017 eclipse on the net, you can find a lot of weather predictions already about where to go along the route and where the best place would be, have the best chance of clear skies and see this solar eclipse. Now at this same place where we were looking at these telescopes, they have another area called a telescope farm. They rent space on their property for people or groups of permanently set up domes containing remotely controlled telescopes for astrophotography. There are several small domes with no people present, all being controlled by their owners all over the world. We observed the following objects that I already discussed on the previous nights. We had a laser tour of the southern constellations, the Tarantula Nebula we looked at with and without a nose-read filter. We saw the Orion Nebula with a nose-read filter, the Hemisphere Nebula, 47 Tucani, the globular cluster, Omega Centauri globular, the football cluster, and then we spent a lot of time wandering around in a large Magellanic cloud, like I mentioned on one of the other nights, where you can just take a very large dot and move it around and spend a long time staring at different interesting objects within the large Magellanic cloud. And then we saw a few objects that we see here all the time: Mars, Saturn, M42 in Orion, the Needle Galaxy in Coma Berenices, and the Antenna Galaxies in Corpus. Here's another view of the Atacama Nebula. It kind of reminds me of the Typhon Nebula, but it has the division lengths like the Typhon does. The southern Milky Way went across the whole sky, from Sagittarius to the zenith to Orion. What I like about this picture is it gives you an idea of a comparison of the brightness of the large Magellanic Cloud to the Milky Way. The center of the Milky Way is certainly a lot brighter than the large Magellanic Cloud. But of course we see all the rest of the Milky Way too, and the large Magellanic Cloud is brighter than the rest of the Milky Way. Now the Big Dipper, we've all seen the Big Dipper look exactly like this, because when the Big Dipper is at the highest in the sky, then we see it in the summer, way, way high above Polaris. We see it upside down like this. Well, they only occasionally can see the Big Dipper in the southern hemisphere when it barely comes above the horizon and it has this upside down appearance. So you can't see the horizon in this picture, but imagine at the bottom of the picture. So I was just amazed to look at the Big Dipper upside down and see it right at the horizon. They have an object there they call the Southern Pleiades because they're jealous of our real Pleiades. It's the Theta Carinae open cluster. It does have some resemblance to the real Pleiades that we see in Taurus. It can be seen naked eye, though it's 70% fainter than Pleiades. It contains 60 stars about 480 light years away from us. It's brightest star is magnitude 2.7, while its other stars are all magnitude 5 or fainter. It appears 50 arc minutes in diameter, about half the size of our Pleiades. Here's a cluster of galaxies 62 million light years away, the Fornax galaxy cluster. It's in the constellation Fornax, the Furnace. In the southern hemisphere, they have constellations with names of more or less modern objects like Furnace. There's a constellation named for a telescope, a sextant, because these were named by European explorers who, quote, discovered the southern skies, as if nobody had lived there before, and named them for objects that were familiar to them. Unlike the names that we have for our northern hemisphere constellations that were named thousands of years ago after Greek gods and so on. Here's NGC 1365. It's called the Great Barred Spiral Galaxy. It's 56 million light years away in Fornax. Its 10th magnitude, it measures 6 by 11 arc minutes. 4 supernovae have been observed in this galaxy in 1957, 1983, 2001, and 2012. On the lower right is what it looked like to me in a 17-inch dot, and on the left you can see an astrophoto, but it gives much more detail. Here's an interesting star called Ruby of the Cross. It's close to the beta star in Crookes. It's a very red carbon star called Dy Crucis, Ruby Crucis, or Ruby of the Cross. It's 9th magnitude compared to the beta star in the Southern Cross, its 1st magnitude. It's an optical double, not a true double. An optical double means it's just in the same line of sight as the other star, not really orbiting the other star. A carbon star is a red giant whose atmosphere contains more carbon than oxygen, forming some carbon monoxide and other carbon compounds. The carbon dust acts like a filter, producing the red color. So you can see it as 3 magnifications here. On the left, you see it as just a little teeny red dot, just barely above the beta star and the Southern Cross. In the center photo, you see a greater magnification, so you can see the red star more separated, and then a larger magnification, so you can see it apart from Beta Crucis. Well, they not only are jealous of the Pleiades, they're jealous of the Ring Nebula as well down there. NGC 3132 is a planetary nebula in the Vela, the Sails. At 2,000 light years away, it's 10th magnitude, and it appears 62 by 43 arc seconds. Compare this to our familiar Ring Nebula in Lyra, M57, about the same distance from us, 2,300 light years. A little brighter at 9th magnitude. They're appearing much larger at 230 arc seconds. But the southern ring does have one advantage. You can see its central star, that we don't get to see in our telescopes when we look at our Ring Nebula in Lyra. The Horsehead Nebula, we've all seen many beautiful pictures of the Horsehead Nebula. But I've never been able to see the Horsehead Nebula with my eyes, only in a photo. I've never been able to see it in a telescope. Some people have told me they have seen it in the telescope from here in the northern hemisphere, and I've looked and been unable to see it. But here I finally did see it in the telescope. We were in a nice dark sky area. It was very high in the sky, so perfect observing conditions. We had a big scope, a 24-inch dot. And I certainly did not see it looking like a horsehead, but what I could see is a little black speck interrupting this brighter nebula. Well, the next day, as usual, we went off sightseeing. This will be April 2nd. We had to go in smaller vans instead of the large bus because we were driving off-road on some unpaved areas down the center of a long, wide canyon in order to get to the Rainbow Valley. The Rainbow Valley is a beautiful valley in the desert with multiple colors of hills with mineral deposits causing these colors. The green hills and scattered green rocks are made of serpentine, which is hydrated magnesium silicate, and of hydrated copper sulfate and copper carbonate. On the lower right, you see just a close-up of a little rock on the ground to give you an idea of what kind of rocks are making up these hills. I believe yes, I'm wearing the Warren Club shirt and the Warren Club hat.
You're in shirt sleeves, John.
Yes.
Was it warm?
Quite a difference from cold places to hot places. We had quite a range of temperatures on us. There's a lot of rock formations here in the Rainbow Valley. Must have been some water here at some point because you have these deep tubes that I think had to have been carved out by water in the very distant past. More interesting rock formations that really look like they had been carved out by water. You can see some green rocks and a few dry shrubs in the foreground. A group of llamas walked by us. They had ribbons in their hair, so I think they must be owned by somebody who felt like decorating them. We didn't get to eat any llamas. We did, however, have lunch here in the desert. The tour group brought along sandwiches, and we set up tables in the shade of one of these hills, and had our lunch just sitting on the ground. Then we went to a place called Moon Valley. This is a dry lake bed covered with a layer of salt. All the white that you see is salt. It hasn't rained here for hundreds of years, so the salt just sits on the surface. Obviously, there was some salty sea here long ago. The sea dried up, leaving the salt on the surface. And in a normal place, that salt would have been washed away many times by the rain. But here, since it absolutely never rains, the salt just sits there as crystals on the ground, and when you walk around, it goes crunch, crunch. The Science Telescope editor, Bob Noya, was with us on all the sightseeing trips, in addition to the observing, so there was lots of great opportunities to talk to him about astronomy. There were large glowing sand dunes along the margin of the valley, and you can't really get a good view of how great these look, but they're constantly wind-blown, and so they're just perfectly smooth. Next, we went to a place called Mars Valley. Now, next year's Sky and Tel trip, I think, is to Mars, but we haven't been there yet. But I've seen a lot of pictures, and this does not look like Mars to me. But they call this Mars Valley, nevertheless. Here in Mars Valley, we had a beautiful view of the sunset. I'm standing with my back to the sunset, looking east in this photo, and you see these beautiful colors in the east. As all of you know, love to look at sunsets, you have to look in both directions. You can see beautiful colors behind you as well as in front of you at sunset. Well, the next day, we went to see geysers. El Tatio is a geyser field in the Andes Mountain. At the highest point we went to on this entire trip, 13,000-foot elevation. We have 80 active geysers, which I'll explain in a moment about why we were there at dawn and how these geysers work. But first, let me mention we had to get up at 5 o'clock in the morning to get to the geyser field at dawn. And we were all grousing about this until we stepped out of our hotel room into the dark parking lot and looked up and found that this was the only opportunity of our trip where we were going to see the center of the Milky Way straight over our heads. Because at this time of year, the center of the Milky Way was directly overhead at 4, 5, 6 o'clock in the morning, not in the evening when we were doing our usual observing. So it turned out we were really glad we were up at 5 o'clock in the morning when we got this amazing view. We also saw Venus and Mercury that morning. So back to the geyser fields. We got to the geyser fields at dawn. The temperature was 25 degrees. There's boiling water coming up out of the ground. These geysers are different than the geysers we have here at Yellowstone. Instead of water shooting in the air, these have steam shooting in the air. There's hot water constantly boiling up from the ground. As the boiling water evaporates, it creates a column of condensing water in the air above it. This condensation is most spectacular when the air is coldest, so that's why we had to be there at dawn. So this water's boiling up all the time. It's evaporating into the air all the time. Obviously, you can't go at night because you can't see it because it's dark. And if you go in the afternoon, the problem is the air is so warm that you don't get as much condensation. So the ideal time to see this is right at dawn when you have light, but the air is as cold as can be, so you have the maximum amount of condensation to make the most spectacular steam.
So it's well below freezing at this point.
Yes. In some places, the boiling, evaporating water leaves a little mineral pile behind, so you have a lot of little hills made of minerals. We put our eggs for breakfast in little cloth sacks and dipped them into the boiling pools to cook them. This is me holding an egg. And being very cold. Now, there are some wet areas not too far away. We drove about a half an hour and went to a place called Putana Wetlands. And here we saw some vicuñas. These are South American animals related to camels. They live in the Andes Mountains.
These are wild animals?
Yes, these are wild vicuñas. And we stopped by to see some more interesting shaped cactuses in a place called Buitan. That night we had our group farewell dinner, chatting with all our new friends about our wonderful visit to Chile. This was one of the few dinners that was actually included in the tour package. And then we were ready for our day of departure the next morning. We had to fly back from the Atacama Desert to Santiago, the only place you can get a plane back to the United States. And we flew back in the morning, but then we had to wait around most of the afternoon because most of the flights out of there back to the United States went at nighttime. Interestingly, they have cartoons in their safety videos instead of live people in the safety videos. And now I'm famous. As you can see in this group photo of our tour group in Chile, in Bob Noya's column on page 6 of the July issue of Sky and Telescope. That's me in the back row, right there. So I can say I've been in Sky and Telescope magazine. So what did I learn? I can't teach physics, but I can show you pictures of my travels. There's no such thing as too many name tags. Geezers saw geysers, a bunch of old people on the trip, just like in our astronomy club. I felt the earth move under my feet. It's great to spend a week with geeks who all love astronomy. It's always handy to have the editor of Sky and Telescope along. And the Tarantula Nebula is the most amazing and wonderful object in the sky.
John, I thought I remember that Ada Carino was one of the first targets of the Hubble Space Telescope when they put it out and discovered the optical problems.
Yes, it was one of the first objects. I don't know why they looked at that open cluster as the very first object. It certainly Hubble picked a nebula. That would be what I'd be most interested in seeing first in the Hubble.
Well, star cluster would be better to test the optics for pinpoint accuracy.
The answer to my question. Thank you, Marty. You need a star cluster instead of a nebula to test the objects. Its nebulas look fuzzy. Thank you. Okay, well.
For those optics, they didn't need.
I'm sorry?
They could see the problem with the fuzziest of objects.
Any other question?
Although I wanted to say the llama with the pink ribbon was actually kind of famous.
I'm sorry?
The llama with that pink ribbon in its hair, those are actually kind of famous. They're called Dolly llamas.
I see. Okay, we won't be calling on Marty for any more comments.